Well, welcome everyone to the March Gardening Club call. I have a really exciting lineup today. Several folks and teams from the ecosystem that are going to give us an update. Our agenda is kind of a standard format. We just kind of have quick welcome and announcements, and then we typically have a few teams that are scheduled for kind of dedicated slots, if you will. And today we have Nighthawk and Zondax who are going to give us updates. And then we try to reserve about 15 minutes for an open mic time period. We do have a couple of projects that are interested in talking during that time today. Moeta and Ziggurat, if I'm saying that correctly, are going to give us an update. And then we should have about 5 minutes in that, 5 to 10 minutes left for anyone else that wants to hop in and give a project update. But let's see, so let's get going. Just a few general announcements since the last gardening club call. Christina Garman joined the ECC board of directors. Christina was one of the original 7 scientists who invented Zcash. Really excited to have her on the board. ECC released its transparency report for Q3 2020. And just kind of a note, since ECC is now a wholly owned subsidiary of Bootstrap, which is a 501(c) org. This is our last transparency report. Reporting will now shift to an IRS Form 990, which is kind of a transparency report in and of itself. So rather than duplicate efforts, we'll just be doing all reporting on that form going forward. And then we also formed the Scientific Advisory Group, the ECC Scientific Advisory Group, consisting of 5 members initially: Arthur Breitman of Tezos fame, Vitalik from Ethereum. Mary Mahler is also at the Ethereum Foundation as a crypto researcher. At the moment, Mary has a distinguished history in zero knowledge technology, so great addition. Zucky, is Tendermint, Cosmos fame, and Gordon Moore has been around since the early days of the internet, working on things like Smalltalk, Internet Archive, and in particular, crypto economics is something that is a great skill he has. So we're looking forward to working with all of them. We have a kickoff meeting later this month, so we're looking to get going, and we're looking forward to that. So in terms of presenters, our first one today is Nighthawk, and I know we have Addie on the call. So do you want me to just keep the slide up here, or would you like to present yourself, or how would you like to do that?
Hey, Stephen, I do have some slides, so I'd like to share my screen.
Okay, all right, sounds good. Let me stop sharing and I'll turn it over to you. Let's see. Okay, you should be able to present now.
All right. Hello, everyone. I'm Addy from Nighthawk, here to give you an overview of our progress in the Zcash ecosystem. So as we know, Nighthawk is a shielded wallet for Zcash with support for sending and receiving ZEC transactions and memos via Z2Z and Z2T transfers. A bit of a recap: since the Zcash Foundation's funding of Nighthawk last year, we forked the Zcash wallet repo and got it ready for release, getting rid of any analytics or privacy affecting libraries. We then shipped the release candidates based on beta software to the App Store and Play Store, and now we have 1,000 plus monthly active users. We also fixed several user reported issues and kept up with changes from upstream while providing support for our early users via Twitter and email. We optimized our Light Wallet D operations and set up public infra for Zcash Light Wallets. And recently we started work on building an efficient, privacy-preserving block explorer. Here's a snapshot of WAMC's progress till now on the block explorer. The front end is using Tailwind CSS hooked up to Zcash D directly. We plan to finish the front end using Phoenix and ElixirLang before moving on to developing the block injector and the Zcash specific features like payment disclosures. We learned a lot from hosting Light Wallet D infra for Nighthawk last year and decided to make available a load balanced public infra for the Zcash ecosystem. like the Zcash Cold Wallet, which is using the Lightwallet service. The endpoints are available at lightwallet.com for any team in the Zcash system to use the Light Wallet service. And the performance of our setup has been great so far, and we plan to rely on it for the Nighthawk mobile wallets for the rest of the year and going forward. As for the 2021 roadmap, um, we know that Zcash mobile users want a fast and good looking app, and developers need to strengthen the underlying code base, that is, the Zcash mobile SDKs and upstream wallet repos on which Nighthawk relies on. On the design front, we need to be on par or better than the top finance apps out there. That is the standard we want to set for ourselves. Feature wise, we are looking for a release on F-Droid, the Google free alternative for our users, and an exchange integration for quick purchase of ZEC, and adding user guides and multi-language setups for our international audience. So all thanks to ECC team, they have been super supportive on every front. Andre with introductions to exchange partners, Kevin and Paku helping out on all things mobile, and the wizards, Chris, Strad, and others behind the scenes doing their magic with Rust libraries. So we rely on all those underlying suite of software from ECC to power our apps. By the second half of this year, we plan to have an operational block explorer to complete the end-to-end free software experience for Zcash users, preferably delivered via Tor network. We are following the updates on the RT project and possible other Tor library work, which can improve the network level privacy. And all the code and designs for Block Explorer, the mobile wallets, and light wallet customizations that we do will be open sourced and free to fork by the community. For what's next, we listen to our users and we know that the Zcash community has many expectations from the teams developing software for Zcash, all for bringing financial privacy to everyone in the world. So, on the design front, adding a designer to our team would help with simplifying the design language and to conduct user studies for improving overall usability of the Nighthawk app. And in order to get there, we believe that we need to focus on the underlying software to build a stable base, and then we will be free to customize and extend the app on the user interface layer, adding several integrations like Flexa and other top level exchange integrations. So we are on the lookout right now for experienced Swift and Kotlin language developers who are ready to contribute in resolving the outstanding issues on Zcash, Android, and iOS GitHub repos, and to build a stable and beautiful app that Zcash deserves. That is all from me. Thank you very much.
All right, thank you, Addy. Question for you. Yeah, great job. And Brad echoed that in the chat, but yeah, great job on that. And we really just enjoy thoroughly working with you and your team. I had a question for you on the, if you don't mind, if you could go back to the roadmap slide that you had up there.
Sure.
Yeah, that'll prompt it. Let's see. Yeah, that looks good. Um, kind of one of the things we're really interested in is we provide the SDKs and kind of the reference wallet app, and then what we don't get is direct user feedback. So we're super interested in your user feedback and how we can strengthen the SDKs. And I know you work with Brad and team, on a regular basis, Kevin and Paku. But just, yeah, anything that so I was just one was kind of a request, anything you see on the user side that would help, make the SDKs better, just make sure you bubble that up to us. And then I had a question also about I think you mentioned maybe on the next slide, you plan to do like a user kind of a study to pull in some user feedback on, kind of to kind of improve the user experience. Is that something you kind of have a focus group planned for, or how are you going to collect that? Or is that just some of your maybe alpha beta testers that you leverage heavily?
So those are great points, Stephen. So first of all, we have been having like ad hoc communication. So maybe we can streamline that communication in the form of like proper channels, maybe through the GitHub or email chain to relay our user feedback back to the ECC team. And as for the user studies, a couple of contributors have spent their own funds to do their studies and kind of reported the feedback to Nighthawk. And I'll get back in touch with them and see if they are open to share their feedback because they have actually paid actual money to uh, conduct these studies, and I was not
Hmm.
sure if they want to open source all of that.
Right.
Mhm.
Okay. All right. Very good. Okay. Any questions? Anyone? I've been kind of keeping an eye on the chat. If anyone has a question, you can just ask it in the chat or raise your hand. There's the contact info for Nighthawk team. So if you're interested in working with them or just have feedback, as a user of the Nighthawk wallet, be sure to get in touch with them and let them know. All right. Well, I think I don't see any questions, so we'll move on. Oh, hold on. Let's see. We did have something in the chat. Paul or Parker, sorry, said please integrate Zec pages into Nighthawk. And then we had a Matt indicated, yeah, it looks great. Not a question from Parker, obviously, but yeah, we've actually talked about that. That'd be kind of cool. Zec Pages is a really neat app. I know Zuko's kind of been a fan of Zec Pages and that type of integration as well. So very good. Okay, sounds good. Let's see. If you wanna stop sharing your screen, then I'll get pop the screen back up. Um, let's
Okay,
see.
got it.
Okay, thank you. Yeah, appreciate it. Um, oh, very good. Okay, so Zoe from Zondax, are you ready? Do you want me to pull the one slide up that I have in there kind of as a placeholder, or did you have something you'd like to present? Oh, okay, Leon is the presenter from Zondax. All right, then let me promote. Okay, let's try that.
Yeah.
Okay.
Can you hear
Uh,
me, Steven?
yeah, we can. Yeah,
Cool.
sorry about that, Leon.
No problem.
Did
No
you want
problem.
to?
I couldn't say anything.
Yeah, did you have slides you wanted to
Yeah,
present?
yeah.
Oh, okay.
I have a few slides present.
Okay. All right. Go ahead.
Uh, can you see these?
Yes. Mhm.
Cool. All right. Yeah. Thanks for joining, everybody. I will give a quick update on milestone 3 of the Zcash Ledger app that we made. Um, Just a quick slide about Zondex. We are a technical partner of Zcash, and we are a team of software developers and engineers. And we are, among others, specialized in HSM software and integration, but also more general blockchain backend engineering. And if you would like to see more information about Zondex, you can go to the website. So for this specific project, we completed milestone 3. And in summary, this includes the following functionalities. We support full zip32 addresses, so also shielded addresses that you can view on the screen of the ledger. We have full sapling support, so this includes both shielded and unshielded inputs and outputs. We have a full transaction review in the UI so that users can actually verify the thing that they're trying to sign. There's full integration tests between the ledger and the host. We had to make a custom transaction builder to handle specific interactions with the HSM. I will come back to that later, but mainly this is because we don't expose the secret signing key. That's something that stays in the HSM. And we have published full JavaScript libraries and Rust libraries for the integration tests, as well as a Rust crate that hopefully helps with third-party integration. So just to describe the complex setting that we're dealing with, the Ledger Nano S has only 4 kilobytes of RAM. And when we highly optimize everything, we get to only about 2.8 kilobytes of usable RAM. So we had to use a lot of tricks to optimize memory usage. Basically, we rewrote a lot of the cryptography that's part of March Zcash, and we rewrote that to optimize for memory usage. Another thing that we had to deal with is that the screen of the ledger only shows 35 characters at a time, so we had to stream the data on the screen. And Zcash has a lot of Zcash-specific cryptography. That means that, for example, the ledger has built-in hardware support for SECP256K1 or ED25519, but not for cryptography that Zcash is using. So, for example, no support for Job or the Peterson hashes. So we had to rewrite them ourselves in this specific memory environment. It's a hybrid implementation, and that means that we expose some of the functionalities to Rust because that's also the language that March Zcash is written in. But we also expose some parts, for example, the hashes, the Blake2B hashes, or some arithmetic from Job. We expose that to the SDK that the ledger provides, because then like you want to use as much as possible the hardware support from the ledger. And on top of this, Zcash also has a bit more complex workflow because, like I said, we support both shielded and unshielded inputs and outputs. But for these shielded inputs and outputs, we also need to construct zero knowledge proofs, and that also need to interact with the ledger. We want to be as secure as possible in the sense that the ledger verifies as much as possible that it can. So usually the workflow of the ledger is like this. There's two parties, so to say. The host, that's your PC normally, but also a mobile phone can be the host, and we have the client, that's the ledger device. And the host, you gather your transaction data on screen, and you push this to the ledger. And then on the ledger, we show the transaction data on screen. So you show inputs and outputs and values and transaction fees, for example. And then as a user, you say, I accept or I reject. And if you accept, then the ledger generates a signature, and you give back the signature to the host. And then the host can finalize the transaction by adding the signature to the transaction. So this is like the normal workflow. But for Zcash, we had to do something quite different. The first phase is the same. Basically, the host gathers transaction data and sends this to the ledger device, and we show the specific inputs on screen, and then the user has to say accept or reject. But at that point, we differ from usual apps because we need to send a bit more data to the host, back to the host. Now, at the point that the client accepts a transaction, we store this transaction data that we just verified on screen. We store that in Flash. There's a bigger Flash storage on the ledger device, so we can use that to store this transaction data. And then we send a bit more data to the host because the host needs, for example, the proof generation key or an outgoing viewing key. And those, we only expose those parts to the host, so not the full signing key. And because a spend can have, like a spend node is associated with an address, but that can have multiple zip32 paths, so you can have like different paths leading to your addresses. That also means different keys. So at this point in time, we send everything that the host actually needs. We send it to the host, and so the host collects all this additional transaction data, and then it generates the zero knowledge proofs for the shielded spend and shielded outputs if there are any. And once that's done, the host sends back this transaction blob basically to the ledger. And now the ledger has to verify things, because we only verify these specific parts on screen, but the host actually sends back a lot more stuff, and we sort of combine these two things and we check, is everything correct? So among other, we check if people are familiar with cryptography, we check the node and the value commitments, we check encryptions of the memo. We also check if the correct randomizations happened, because actually the ledger defines what random values should the host use for generating these proofs. So we also cross-check that with what the ledger actually made. And if everything is okay, then we send back the signatures. And these can be multiple signatures, because you can have multiple spends, you can have multiple transaction inputs. So, but at that point in time, when everything is checked, we actually return everything, and then the host can add all these transactions to the can add all these signatures to the transaction, and then finalize the transaction, so to say. So I hope it's a bit clear why the Zcash Ledger app is a bit more complex than usual, but we managed to fit everything in this restricted environment. So I included some pictures. I don't have a full demo, because currently a full transaction, including zero knowledge proofs and including like clicking through the screen to verify all inputs, that takes about 9 minutes. And we do have some ideas to speed this up, but those are not in place yet. So, but yeah, I made some pictures myself, so I hope you can at least verify a bit. Like I said, we have full support for transparent plus shielded, so a transaction can have both. We only support from all these inputs, or shielded inputs, shielded outputs, transparent inputs and outputs. We only support 5 at the moment, because that's the roughly like filling almost the whole flash memory. So that's also not that much that we have. But yeah, as a user, you can in any case check all these inputs. So yeah, the first step you do in such a transaction is checking transparent inputs. You can verify the address, and you can verify the input amount. And internally, like in the checking of the transaction, we of course use things like BIP44 to actually recompute this transparent input, that it's actually something that the ledger also knows. Similarly, for a transparent output, you can view the address and you can view the amount that you're sending there. Then for shielded inputs, it's also like you would expect. You get an address and an amount, and internally we use zip32 to recompute this shielded address. And then a shielded output is a bit more complicated, because you have an address, you have an amount, there's a memo involved. We cannot, because we only have 35 characters at a time, you can and then parsing, I think a memo is 512 bytes. That's gonna be a lot of clicking. I don't think people want that. So what we did is we show, is this a default memo or is this something custom? So like if it's something custom, then yeah, you at least know that you're sending that and you're not sending a default thing. And then for the OVK, the outgoing viewing key, for those who know it, you can either set this to none, like just leave it empty, or you send an outgoing viewing key. And then the remainder is checking the transaction fee. And this is compliant with ZIP 31313. And then a user accepts or rejects. And then you go into these steps I described, like, okay, we have to check a lot of transaction data, and we also have to send a lot of data. So to know that that the device didn't freeze, we actually have some sort of status update, like you're at step 1 out of 5, for example. That's what you start, and then if you're at 4 out of 5, you can at least know that you're almost done.
So what's the scope for improving that length of time? What's the bottleneck at the moment?
I think rechecking all these Peterson commitments and the encryption. So I think I think at a certain point we could give the option that you don't do every single check, but I mean, right now we built in every check. So, but as a user, you could say like, okay, I only care about values, for example. So then you check the value commitments.
I guess maybe the host could produce a zero knowledge proof that it's done everything correctly, and you could just check that.
That's also an option. I'm not sure how much faster the check. I mean,
yeah, it depends how big the proof circuit would have to be, I guess.
Yeah, and it's a tiny device, so the bottleneck is really like doing a Peterson hash, for example, takes maybe like half a minute already or something. Like you have to think in that order. Like it's slow because we don't have all these hardware accelerators like they have for SecP or for E519. So that's yeah. But yeah, there are of course like shortcuts, but this is the current functionality. Yeah.
Okay.
Yeah, just to wrap it up, we made everything public. So in Ledger-Zcash, there's the repository for the app, including Nano S and Nano X, and we have several build instructions. And like I said, we published these Rust crates for both integration and testing between the Ledger and host. That's at Ledger-Zcash RS. But please don't use any of this in production, and especially don't use a device that has funds, because there's still a lot of work in progress, and well, not work in progress, we have to submit to Ledger, and Ledger will review this, and it will support installation. That's also a lot cleaner than doing this development installation yourself. That's it.
All right, so we have quite a few questions and comments in the chat, so I'll kind of move through those, then you can respond. So Chris, I promoted you to panelist, so you could ask your question or make your comment on Transaction Builder.
Yeah, so I just, you mentioned that you had forked or created your own Transaction Builder, and in the process of refactoring the Transaction Builder for the purpose of supporting Orchard, it would be just really useful to fully understand the data flow, so that can be built into the Transaction Builder abstractions, so that you don't necessarily have to continue maintaining a fork of transaction construction.
Yeah, that would be very useful. Like, yeah, the main idea is that the current Transaction Builder used the secret key, like the full secret key, and we don't expose that. We expose different things, and like we don't expose the secret signing key, but we give back signatures. And yeah, like the proof key was generated from the secret key, but we only give the proof key.
Okay.
Yeah, so those things indeed, like if that's in a new builder, then yeah, that would definitely help.
I think those things should be in the builder anyway. Yeah, independent of the specific use for Zondex, because we'll need it for other hardware wallets as well.
Good point. Yeah, so I mean, we can just kind of follow up Chris is in the middle, as you mentioned, of refactoring Transaction Builder, so we can follow up, directly with you, Leon, and the team to kind of make sure we capture your needs in there. And then there was a question from either Andre or Dara. What's your estimate for how fast the transaction can be done with all the optimizations that you've made? Although I believe you may have answered.
I think you answered that already.
Yeah, that's what I was going to say. I just want to make sure.
I don't dare to make like estimations for that. Like it's always slower than you want,
right?
And slower than you think. Yeah, I don't dare to say something like that.
All right.
I guess I just need to review the code and see if there are any optimizations that you've missed that would make a big difference.
All right.
So one quick question with respect to testing. I did spend an afternoon attempting to build and see if I could get this on a spare ledger device. It wasn't clear to me, based upon the build instructions you gave, how one actually, in the absence of Ledger Live, how you actually interact with the device once you have the build installed.
You could, for example, in that case, use the Rust integration crate that we provided.
Okay.
Those have specific, you can just do cargo test and one of the integration tests, and that will push things to the ledger. You could also, currently the JavaScript tests are in the emulator. So there's an emulation package that Ledger provides, and we made integration tests in the emulator. So we also run that in continuous integration. But you could tweak that to send it to the, there is a JavaScript library that you could then also use to actually push it to a device and not to the emulator.
Okay.
But yeah, I think the easiest way is to use the Rust script.
Okay. Thank you.
Okay, so Addy had a question with the limitations of a Nano S. Would it be easier to get Z to Z working on a Nano X?
Yeah, for sure. I mean, that's the goal was Nano S, so we build everything for Nano S so that it's like fitting on the tiniest device. But Nano X will, that will of course also fit, and probably it will be faster, but I don't know.
Okay.
Like I didn't do any timings on a Nano X.
Okay. All right. Very good. And then Walter had a question. Is it the usual 24-word seed?
Like from the ledger, yes. So internally, you indeed use a 24-word seed to seed your ledger. And what we do is we generate a secret, like based on a certain path, like a fixed BIP32 path. We generate a seed, and from there we go to zip32.
Okay. All right. Let's see.
Yeah, we need to write a zip about exactly how that's done so that it can be interoperable.
Yeah. I agree.
So a couple of other questions. One is a general we'll wrap up with. How can folks get in touch with you to give you feedback or if you need additional testers or whatever, or if they have questions about building. So we'll get that from you in a minute. There was a question from Parker. Was there a date announced on when this functionality makes it into Ledger officially?
I don't think there's anything official yet. We are currently looking for cooperations on integration, and then I think we can move forward. Yeah.
Okay. All right. And then question from Brian, is Zondex considering working on or submitting a grant application to work on Trezor?
I don't know that.
Okay. All right.
That's something that Juan probably knows.
Okay. All right. Sounds good. I think that covered the bulk of the questions in there. So what's the best way for folks to get in touch with you and the team at Zondex?
I think there's in any case some way to contact Zondex through the website. There should be a contact form. It's zondex.ch.
Okay, zondex.ch. Okay.
Yeah. Another, like if you have specifically for this app, you could of course go to GitHub and
Okay.
Make an issue or something.
All right. Very good. All right. Well, thank you. No, this is super exciting. It's been great to watch the project evolve. So, yeah, super exciting. All right. Okay. Well, thank you, Leon. Let's see. So the next slot is kind of our open mic slot. We had two groups that were interested in speaking for a few minutes. One is Moeta, and I don't know who from Moeta would be is on the call or wanted to chat. The other one was Ziggurat, if I'm saying that correctly. So if you're with one of those teams, if you just want to raise your hand, I can promote you. Or if Janie or perhaps Andre or Elena knows who they might be, I can promote them as well. Oh, Elena can't see attendees. Let's see. Hold on one moment. We'll fix that. Yeah. So once again, if you're with Moeta or Ziggurat, which is the testing framework, there was a recent grant for. Just raise your hand and we'll get you promoted so you can chat.
And that raise hand button should be directly above the chat box for you.
Elena, do you recognize anyone? Nope. Okay. Well, we'll kind of move on. The open mic is, we just had a couple of groups that had expressed interest. They may not have been able to make it. Is there anyone else on the call that has any comments or feedback for Zondax or Nighthawk, or who would like to chat about a project they may be working on or involved with? And I'm feverishly scrolling through the participants to look for hands. So. No. Okay. Well, I guess they couldn't make it today. Oh, hold on. Let's see. Yeah, yeah, that's what I was about to do, was wrap up early. Okay. So yes, Chris. I think Chris did ask about the build environment. I'm assuming, Walter, you mean for Zondax. Yep. Okay. All right. Okay. All right. Well, look. I believe that's it for today. Then, and we'll get the two folks that wanted to chat. We'll coordinate with them and get them back in to a future gardening club. But thanks everyone for attending. And again, feel free to reach out to any of the teams that presented here. Reach out to us at ECC if you'd like to present a project you're working on or that you're involved with, or that you just like. You want to suggest it, and we can reach out to the teams. We'll be more than happy to do that. So everyone have a good rest of the day, and thanks again for joining.